Thank you very much, and thanks, of course, for having us here. My name is Yuval Dimnik. I'm the co-founder and CEO of NooBaa. Together with me here in the room is Guy Margalit, our co-founder and CTO. And we'll tell you all about what we do and how we do that and why we do that. I'll start by a very, very high-level presentation of what it is, and we'll talk about the agenda, and hopefully we'll make it interesting. So NooBaa starts the first product that we launched as of yesterday, provides a cloud service that the customer owns. And this is what we're going to cover in the next few slides, of course, in the next hour. We're going to talk about, of course, the company, where we come from, what we're doing, why we're doing it, especially maybe. And of course, this is Tech Field Day, and as you already heard, we've been spending Saturday night in Las Vegas in our hotel room coding. So it's a geeks discussion. We are geeks. We love to discuss technology. So we are not shunning away from anything related to technology. So we would love to have the discussion.
But all work and no play makes for dull boy.
Yeah. Well, if there are any subjects on the agenda that are missing or that you want to discuss, you can bring them up now. We will see if we can cover them. My guess is that we might not have the full time due to the short time that we have. But we are very eager to have those discussions, so we can take them offline in whatever format you see fit, or the customers or users on the web. So we'll work this out. So I'll start by introducing myself and Guy and some highlights about the team. So Guy and myself met about 11 or 10 years ago in the file system core team of a company named Exanet back then. We sat back to back in the same cube, coding our way into the core system of Exanet. Exanet was a scale-out NAS system, later on acquired by Dell, currently being shipped under the Dell Fluid file system. And I guess that now with the acquisition of EMC, that's going to take even more traction, and you're going to see more of that in the future. We cared and loved for that company and for what we did there, but we've actually learned a lot of stuff, so we'll tell you about it later on. I'm not going to introduce the rest of the team. I'll just say some stuff about myself and Guy. So both of us started our journey in storage in Exanet. I was a coder in the file system team. Going diagonally up, I was wanted and had some favor working with customers. So in my last position, I was director of system engineering, pre-sale, post-sale support, working with customers on projects and supporting them in the process. And that is a very important key element, and I'll talk about that going forward. Guy, actually, we started the same cube, but he actually dived down. And of course, I've seen him in the corridors, but he was the file system architect for Exanet and later on in NAS. And he knows all about unstructured data and storage, and this is the guy. We have a great team that knows, and we have a DNA not only in storage, but in security, clustering, network, etc. All of them are key to what we're trying to achieve. And we feel that we have a great take at the market. Company was founded 2014. We've launched a product as of yesterday, and you can actually take a stab at it right now. And the head count is currently 14 employees, mostly in the Israeli Development Center, with some footprint here in the Bay Area for sales and marketing. So without further ado, I'll start by telling you about our experiences from the past. And this is a story. I don't even have a slide for that. So when I was in the field, both with Exanet and with Dell, and I actually witnessed it also now downstairs here on the floor, the vendors go to customers and they tell them, well, we have this solution and it does this and that, and we have this feature and the other feature. Customers don't really understand the difference between the wraps. For them, it all sounds the same, and those are not the questions that they care for. They don't care for how do you do your technology or what's the name of your feature. What they care for is real-life situation. And we've witnessed that, so just to give you some examples, implementation. You go as a vendor to the customer, you tell them about your nifty solution. The customer says, all right, I like the story, what's next? Okay, we'll bring in a demo system, you need to wire and rack and stack it, and then we'll show it to you. Well, that's already a risk. I'm investing time in you, and I'm risking not investing in something else. So that is a good example. Later on, customer is locked down to a platform. Well, what if he wants to change platform tomorrow? What if some nifty thing comes out tomorrow? And the latest points that we saw are choices about the cloud. Customers are, and these are actually the points that we've seen, customers don't really know what the future will be in terms of their cloud strategy, and I'll touch on that. So when we looked at all of these and the problems of unstructured data, primarily data that is created by applications such as IoT or log analysis or archiving or whatnot, these are the things that we saw. So we saw that everybody in the large enterprises are talking hybrid. Everybody's saying, you ask them, what is your cloud strategy? They will say, we're doing hybrid. Okay, what does that mean? Most often than not, for most of these customers, it means that they have some applications or assets in the cloud, some applications or assets on-prem. There's no fabric that connects those two. Okay, if you have some hybrid tool, most often than not, that will be either caching. Here's one of them. Restart required by Windows. Thank you, Windows. I appreciate that. Some caching system, or DR to the cloud, or a gateway, but nothing that creates this fabric that cross things all across. And with unstructured data, you have a problem of data gravity, that if your application needs to access data, write and read that, somehow it's not as easy to transport that if you didn't plan that in advance. So there is a risk factor to that. And organizations are ending up providing a solution by using plastic tape and some other stuff that ends up to go for agility and simplicity, but ends up to be more complex all around for them. Nothing that creates the simpler fabrics. So in NooBaa, this is exactly what we want to do. So we provide a software-only solution that the customers, like large enterprises, can take, and they implement it. And what they get from that is something that behaves very much like AWS S3 service. So it's an object HTTP RESTful API. In the future, we'll go into Lambda. We're not going to deep dive on that today for many reasons, primarily because we're not ready to talk about that, but that is the future if you think about the company, where we're going to take this. The customer owns this service. So there's always a question when you provide a software or how the customer consumes it, etc. Customer implements the software. Customer runs it on resources that they choose to do, and those resources can reside on-prem, they can reside on the cloud, they can reside anything in between. But we're totally vendor agnostic, even to the cloud or on-prem. So in many ways, because the service is being owned by the customers, we actually had some customers who want to use our service, quote unquote, or service that they would create and run it on the cloud vendor that they use, simply because they don't want to lock down to that cloud vendor, which is a risk that we've seen. The service is using heterogeneous resources, and we'll touch on what those resources are, but I'll say bluntly that they are either Linux, all Windows, or a cloud service. These are the services. So the question, if there's a common question, can you tie up my SANs? The answer is no, not directly. But if you connect a VM to those and basically mount that, then the answer is yes. We would piggyback on that, Linux and Windows or whatever. And the beautiful thing about this is that there's no choice of whether this is an on-prem. This can be anywhere. This can be an on-prem solution today. You can span it to the cloud. And I'll show you even how in the demo we help the customers cut the cords from NooBaa if they choose to do so. Because if you say no vendor locking in your DNA, you cannot say we're doing vendor locking, but you're locking you to NooBaa. It's an unfair statement. So we would rather try to do our best and simply keep on to customers because we provide the value, and not simply because the contract is there. So I hope that it provides you with some high level of what we're going to do. And now, everything from here on is for geeks only. I know, well, I'm the geek, so I would be the only one acknowledging that. But from anything on, from this point on, is the internals and how we do stuff. And we'll start with high levels, and we will go down. So I want to start with the design considerations. And the best analogy that I have on this one, and I actually thought about this, is when I watched the Olympic Games. You watch the Olympic Games, and you see these sharpshooters, they stand, and they aim at the target, and they have this perfect thing, and they can shoot perfectly. Great. In real life, in war, this doesn't work, okay? And this is the difference between designing a system to a workload to designing a system to real life. So most often, if you give a system like a storage architect, you tell him, I want the system, for an example, the workloads that we cater for, it's going to have a large object and requires this throughput, et cetera, et cetera. He would sit and come up with the best solution, and it will be the best solution until we meet the real life. And real life, unfortunately, always surprises everybody, and I'll touch on that. So what we wanted to do is we wanted to behave like the cloud, whether it's on-prem or on the cloud, okay? We wanted to consume resources from on-prem on the cloud, and basically we want to remove that barrier that currently exists between on-prem and the cloud and create this fabric that basically is aware of the location, but grants the customer the ability to go anywhere. And this is where the point where in our design consideration we said, okay, let's not design the perfect system to a specific workload. Let's try and understand how will the battlefield look 5 years from now. And guess what? We have no clue. That is, we tried, I mean, we sat both with ourselves and customers, and we said, let's try to build a system not for now, but 5 years from now. What would that system look like? So we asked customers, okay, what is your cloud strategy now and in the future? Well,
I don't know.
Well, I don't know. What is the growth rate now and in the future? Well, they don't know. What is the vendors that you're going to use and what's platform that you're going to use? They don't know. And this is also, we actually discovered that in the painful way. What security issues are lurking and how are you going to deal with them once everybody's going to find out about them? And this is the battle. The battle is not how do you cater for the workload. The battle is how do you deal with these questions? Okay, so I'll run you very fast. The battle is you cannot tell. So you have to define a solution that can cater to on-prem, cloud, multi-cloud, and changes. You cannot anticipate the growth, not in capacity, nor in performance that you're going to acquire. So we said you have to do peer-to-peer. We have to be peer-to-peer by definition, and we have to be scalable and a scale-out mechanism in every form and shape that we can do that, because we've seen where the number of ports, it becomes a factor that basically limits the solution. What about hardware? We said, well, we're not going to do it for Flash because we don't know if Flash is going to be the technology in 5 years from now. Rather, we would monitor the platforms that we're going to use, and we're going to adapt to that, and we change to that. What about vendors? We put a blank screen in front of the developers, and they cannot query anything from the machine. So even if they want to do that, they cannot develop that relationship. Organizational changes, we want to enable you to grow the system, but the reality is that sometimes you have to shrink a system or split a system. So you have to do that as well. And security, how do you deal with security? We don't know how to deal with security, but we do know that if you do things only in user space as a religion, and once you need to fix that, those fixes in the kernel, you can introduce them right away, or you can allow the customers to do that, rather than saying, oh, don't worry, Mr. Customer, we're working on a solution. It will be out there in 4 to 6 months once we finish our QA cycle. Well, I don't know what about you, but I'm very concerned with the hackers nowadays because they're pros. So these are the design considerations, and with that we came to the architecture, which I'll show. So I don't know how many of you are Silicon Valley fans, the TV series. So are you familiar with the Inside Out? So we don't have the Inside Out. We have the aggregate and access. Aggregate and access. So these shapes are the aggregate, and these arrows are the access. So aggregate and access, meaning that basically take resources, and those resources on-prem could be Linux and Windows. On the cloud, it would be cloud resources such as S3 or Azure Blob, whatnot. And we create an AWS-like S3 target that you can use using the HTTP REST API, and then you can access it from anywhere. Again, Lambda, we think that is amazing, and we're going to chase that, but not now. So remember, aggregate, access. So now, when you do the access, when you write data, you'll see why I'm starting to describe with it that now, but when data comes in, we basically digest it, okay? So data comes in, we cut it, fragment it, or whatever you call that. We then inline dedupe it using Rabin, sliding variable window dedupe. We then compress the data. We encrypt the data, and each of those chunks we store on at least 3 locations. That's what we're using today And again, there will be changes but that's part of being adaptable to the future. Okay? So this is easy, and from now it's going to be dirty. Now, high-level architecture, and don't worry, we will give you the gory details of each one of those components, and you will have an opportunity to bug us on why and why not, and we will describe those. Okay? So I want to talk about the components and how we implement them. So I want to start with the middle, and I'll try maybe to use my mouse. So maybe for the folks that are remote. So we provide an OVA that the customer implements in their hypervisor environment. That could be on-prem, that could be on the cloud. We don't really care. There are multiple ones for high availability, which will be available in the future, not in the community version. The community version is only one brain. From that hypervisor, you pull out an agent. The agent is a user space application that can run either on Linux or Windows. You basically put it on resources that are in this side, the other side, cloud, those could be EC2s and whatever. You can also connect cloud resources, such as AWS S3. This is the aggregate. Now that you've aggregated this, it's time for the access. This is the access. Access is being done by RESTful API, either directly to the brain or to a RESTful interface, which is a stateless proxy that you can implement, and you can have as many as those. So this piece is scale out, this piece is scale out, this piece is scale out. These communicate peer-to-peer, these communicate peer-to-peer, and these are some of the discussion points that I mentioned, and I will get back to them as time goes by, because this is what enables us to scale, and there's no clustering. Again, I'm looking for my cursor, but there's no clustering that's happening here. The nodes report heartbeat with information that we collect about them, and we use all that brains in here, deciding where to place data using algorithms, machine learning, and smart placement, and that's the parts that we will deep dive later on. So I want to show you a quick demo. I tried the network before, and it was not amazing, so I apologize in advance if that would not function. If not, we can do it even later. So basically, when a customer implements a system, they implement an OVA, they give it an IP, and this is what they see. So first step would be adding nodes. Adding nodes, as I mentioned, could be Linux and Windows nodes. So in each batch, you can either add this or that, but let's say we want to add Linux nodes. You take this string, you copy it, and you're using Puppet or Chef or whatever to run it on the nodes that you want to add. Each one of those nodes would connect to the brain, would pull out a signed agent, user space application, would install it on that node, and we would basically aggregate all the unused capacities on all of those nodes. If they are dedicated, we'll take everything. If we are sharing it with another application, we will act as a class citizen to that application. Okay? So this is what grants us the ability to actually implement this system in under 15 minutes in a customer infrastructure, simply because we piggyback existing infrastructure. And I can tell you from customer discussions, infrastructure are highly underutilized. Highly. Okay? So it's a great opportunity even to get a foot in the door and get the customer experience that. Again, going back to my experience, we get to a point where we don't discuss with the customer, well, we're bringing a demo machine, and then we do that. The question is, do you see the value? Yes. Let's start with working with it now. Let's see if your application can connect with it now. And if you're happy with it, that's great. If not, we're going to fix it. And if it works, then great. We have a cooperation. If not, kill.
You're using non-utilized storage in the nodes, but actually, what happens if you are utilizing it and then someone else asks for that storage?
So, perfect question. We assume that we are second-class citizens, and we always monitor the behavior of the other applications on that node. We keep some watermarks and some, I would say, defense buffers there, but we can evacuate data faster than the application can write, because for us, it's simply deleting references. So as soon as you consume, we would always shun away from that node, and that node will always be used for the application.
And you have a concept of, different resources for each node available to you.
So each one of those nodes, the answer is yes. Each one of those nodes starts to report a heartbeat, and with that heartbeat, we collect information about those nodes, and that information includes all the drives that we have, their capacity, their drive latency, both read and write, network latency, and that's part of the concept that I told you before of both removing vendor lock-in, being hardware agnostic, and being adopted to new infrastructures. So if tomorrow you're going to introduce to me a new server with flash, we would identify it's flash, not because we're querying it, simply because we get different metrics as time goes by. And guess what? They can deteriorate as well, and we would identify that as well. Okay?
So the node is the appliance that you showed before, right?
The node is a Linux or Windows that the customer has or buys and plugs into the network. We provide so going back to my deck, maybe I'll try and do this.
Yeah.
This is the appliance that I'm using, that I'm using to manage the system. The nodes that are being added are these ones.
Okay, but so data are passing through that appliance, right?
So we'll touch on that. Not exactly.
Okay.
Not exactly.
Okay, but because my next question was, what about very high and heavy access to the nodes?
So I'll touch on that, but just to give you a high-level point, as I mentioned, the data comes in, we fragment, chunk, compress, encrypt, etc. We distribute it on all of those nodes, okay? And by the power of peer-to-peer, each one of those nodes doesn't get a lot of hits to serve a specific workload, okay? Think about, and we're talking about large systems. I mean, this is the future. The future is, you can think of it of only 3 nodes, but you can think of it of thousands of nodes, each one serving just bits and pieces again. BitTorrent is a good example for that that you can run.
So is it kind of like a BitTorrent modeled storage approach inside your own organization? I mean, because that's basically what your instruction is.
I think this is, first of all, not only we're not shunning away from that, we love it. Yes, this is the future. It is a peer-to-peer. It's a combination of. It's a combination of.
It works really well. So I mean,
No,
it's
it works amazing. It works amazing in terms of scale. It works amazing in terms of actually providing you for that workload, which is streaming workload, which is ideal for this workload. So, but BitTorrent by its own is not enough because it lacks the security, it lacks the control, etc. But I would say we took concept from BitTorrent, we took concept from SETI on the cloud, and etc. We took concept from cybersecurity. We looked at those projects and said, whoa, can we piggyback and leverage those nifty things? And actually BitTorrent, yes. And that's why I said, there is some access to the brain, but in Torrent, you don't go to the centralized for everything. And that's exactly what we're doing. And
Which works perfectly to your point is, so if you've got slow nodes, they're going to give you stuff slowly.
Yeah.
But if you have fast nodes, hey, I've got 3 guys who've got the data. Whoever gives it to me fastest, that's the one I get it from.
Exactly.
Sorry.
And that's, yeah.
And for unstructured data, which is what we're targeting, we're not targeting low latency workloads. We're not trying to cater for databases. We're not trying to cater it for virtualization.
No,
and you think about that, in unstructured data, you have so many opportunities to optimize to that. You can classify nodes differently. You can pop stuff in the memory before you even access that. You can start and stream from multiple locations in parallel. You can always saturate the last mile. And that's exactly what we're doing, actually, all of the above.
So
Okay?
I'm sure in your travels you've talked to enterprises. I mean, what's the average that they have out there sitting there basically unused across all these different servers?
So
What's that pool look like from a percentage?
So I would say we are not, from our perspective, using underutilized resources is just a proof point to get the customer to play with it.
Well, it's a CFO sell point. I mean, if you go to CFO and say, hey, look,
you're right.
all this, you've paid for this money. You've already spent the capital on it. Now we have a way to use it. That's big.
My take is that this point it's even more important. I mean, we can drill down on that, but let's say this. The beautiful thing about it is it can function amazingly if you put dedicated servers that you buy and you want to use for that. Okay, it works, and it works beautifully if you want to use underutilized resources, and you can utilize both. So you can start with one, go to the other, change models. We care about flexibility. We don't care about that. But going back to your question, numbers are very low. Like total utilization, usually they don't know. You ask them, how many servers do you have? 5,000. What's the utilization? We think 20.
Yeah.
Most often not, it's 9 or something like that.
Do you have
one,
assessment partners yet to figure that out?
No, we don't know yet. We don't know I won't give you the number because I don't know what the number is.
I suppose you are licensed per terabyte and not per node
We
then.
license it by the amount of data that you manage on the system, not even by capacity or storage.
So I can have hundreds of very small nodes because just I have disks on server.
Yeah.
whatever,
That's okay.
yeah.
That's okay.
Although that does create an interesting networking problem.
Yes. No, well,
Yeah, but actually,
From the storage guy's perspective, that's a great idea.
No,
But-
so,
Yeah,
so
but the network wise-
that was one of the questions going back to the war game. That was
we're
one of the
moving the
concerns.
problem to the network guys. Who cares?
Well, to the
Greg,
point,
it's all your problem now.
to the point that they just partially brought up
Yeah.
QoS/throttling built into it. Because I'm just thinking like, what type of things?
Yes, yes. So the answer is, and we'll show you. And so let's get back to that, and we will discuss it when later on in the deep dive about what is the stuff that we're doing. But I'll just answer that due to customer request, they want to segregate those resources, as an example, into pools. And by definition, usually, most often than not, they're not challenged in terms of networks around those pools. So we take one consideration. This is the first step, and then we'll show you how we deal with the other stuff once you use multi-site. Okay. As I mentioned, those nodes are being added to pools. Each one of those nodes, we collect metrics about the behavior of that node, and you can actually define the pools. You can actually add cloud resources as well. So, as an example, AWS S3 as a resource, you can add that, and now we have the resource. So the resources map is already there and it's out there, and we're mapping it, and we're looking at the behavior. Second step is just connecting the application. The application is using S3 REST API, no news here.
Was that Splunk as the other option below it?
Maybe.
Where's Matt Lee when you need him?
Why are you asking? So I'd say Splunk is the primary use case that we're chasing. Spark archiving, we've seen that as a very painful for customers, especially in the archiving. They need high performance. They need that flexibility going back to anticipating the growth rate they don't know. So that is the point that we want to start working with customers. Actually, that's where we're working with customers nowadays. But it's not going to be only that. So that's why I don't.
No. That's a great use case. I was trying to think of good use cases, and that's a great use case.
Splunk archiving use case, media entertainment as a whole industry is a good use case. In the future, healthcare, PAC system, etc. So the way that I think of it is I look at the data scheme and I say, okay, again, no database, no file sync and share, no virtualization. Where do we have large objects with high throughput or high retention? And it's basically like 80% of the data is nowadays this way, and it's going to grow even more. So you connect an application, and when you choose to store your data, you do it in bucket, just like AWS. And that bucket, you give it a placement policy. So you say, okay, I want to place it on this pool of resource and that pool of resource, and I want to mirror the data, or stripe mirror is easier to understand. We basically keep 3 copies in each one of those pools. So here we have Paris data center and default pool data center, and we are mirroring between these two. We also have in this bucket a policy to have one chunk stored on the cloud, on AWS. Okay, so this is part of what if I want to use the cloud? Okay, you're using the cloud now. In this case, the chunk that we have on the cloud is encrypted. So you're taking a step towards the cloud. You're not forced to go all in, not yet. Now,
That's one of the 3 copies.
So I'll show you what we do. So let's go about the policy. The policy that we have here is mirroring between both of these sites and also keep a copy on the cloud. So now let's look at how that looks from a file perspective. Okay. So if I have a specific object, let's take, and I want to talk about several stuff here. So let's take Danny. I'll have Danny. You'll see why. It's a 43 megabyte video, and you remember I said we chunk it, dedupe, compress, decrypt, etc. So we did 89 chunks. The chunks are between half a megabyte and megabyte in size. We'll discuss that later on. And if you go on and scroll that, you can see each one of those chunks, and we give you full visibility on where those chunks are placed. So because of the policy, we would have 3 chunks on the default site and 3 chunks on the Paris site and 1 chunk in the cloud. Why only 1 chunk in the cloud? Because we assume that they have their own redundancy. They have resiliency. And this is why you can have a system that only uses the cloud, and we would put 1 chunk on the cloud, and you can move it tomorrow to Google, whatever. And this is part of the multi-cloud thingy.
But I can't do 2 on-premises and 1 cloud.
This is it.
That's what he has.
Oh, no, you.
No, he's got 3 on premises 1, 3 on premises 2.
Sure,
and
no, you can. What we would do is we would do.
Number of copies, you mean?
You mean 2 copies and 1 on the cloud?
Yeah.
So what we're currently
Yeah,
doing.
minimum resiliency.
I see. So first of all, I would say in this case, minimum resiliency is 1 copy on-prem and 1 on the cloud. Why do you need?
I'm a storage guy. 2 is minimum.
No. So by having 1 on-prem and 1 on the cloud, you already have 4, because they would keep 3.
Yeah, that's my minimum. I'm a storage guy. I'm paranoid.
No. So four is the minimum. So 2 would get you 4. 2 would get you 5.
Right.
Whatever you want to have, you can have it. You can stripe and you can have it. And the other thing that I wanted to show you is because we have knowledge about the nodes, where data is, how the nodes behave, how they behave all the time, we can introduce additional optimizations. So I'll give you an example. You go into this one has 7 chunks, right? Okay, that's what you said, 3 here, 1 in the cloud. Let's talk about the first one. First one has 13. Why? And the reason is that in movies, most often than not, the first part of the movie includes metadata. That's the first thing, and it needs to be served faster, because once you stream a file, I have to go and actually read that data. So I need to find the first part fast. So I'm giving you more resources, and this is going back to peer-to-peer. You can get amazing streaming performance like.
Are we limited to AWS, GCP, Azure on the road? I actually more care about GCP because it's cheaper.
So I would say at this stage we are cloud agnostic. The answer is yes. Naturally, we didn't nail everything in the UI for the community version yet, but we didn't tie ourselves in any way in the code, and we don't plan to do that.
Cool.
Okay. Again, this is no vendor lock-in. Again, so now I want to show you another thing. So 3 ways to use the cloud. First way to use the cloud is I showed you, like the cloud backend. Another way to use the cloud is actually using EC2 nodes. Okay, you can have a pool of EC2 nodes, and then you can stripe to that. Not natural use case, we would say, because it's expensive, the EC2 storage, but we have some customers that have a lot of EC2s that are provisioned in a certain manner that they don't actually control, and they want to piggyback that. They're not giving away the data to AWS because it's encrypted and deduped, etc. And it's also very transportable to other vendors. So this is the second way to use the cloud.
And I might want to fire off like a transcode job and use EC2 compute for that.
You just touched on what we think will be the future of Lambda, but.
How do you determine which part do you pull? Like for the first one, you have 13 parts. Which one do you actually pull out to your browser or whatever? You just went
to read the data.
Yeah, exactly.
We'll touch on that when we talk about read. We'll talk about read path and write path. We'll give you the full Monty.
All right.
Okay. And if not, we will answer that later on. Okay. Another way to use the cloud is actually to what we call it is sync to the cloud. So syncing to the cloud is actually you give us a cloud bucket, and what we basically do is we would take all the data on NooBaa and replicate it to that cloud bucket natively. And we would keep that replication going on very much like rsync or something of sorts. Okay? Mm-hmm. So we can do it from NooBaa to the cloud. We can do it from the cloud to on-prem, and we can do it both ways. So you can think about this is a great launchpad to the cloud. If the customer doesn't know what cloud strategy is going to be tomorrow, it could be on-prem first, it could be encrypted chunk, step 2, and then it could be this one, which is just.
Do you have some predictive tool to understand how much you will pay by putting stuff on S3?
We can provide it. It's very easy, because if you put stuff on S3, and this is one of the points where we think are key to customers, the main problem with S3 is not storage. It's mostly egress network. That is point that you can anticipate. If you go back to this point, you have the data on-prem and it's persistent on-prem. Sure, you can have Amazon for applications that are running on Amazon or DR, but because you don't need to do any egress, then it's very easy to anticipate. You just multiply the amount of terabytes that you have by, 27 per terabyte per month nowadays. This is it. So I hope that this answers to what we do, how do we do that, and how customers can use that.
One more thing. The community edition, the only limit is 20 terabyte.
20 terabytes of data that you store in the system. Yeah. You can have it on 3 copies, 7 copies. We don't care.
20 terabytes of aggregate object size.
Yes, exactly. And this is the way that we want to price in our business model. It is very much like the cloud. Again, we acknowledge the fact that we are a software company, and that's what we want to do. We want to provide the best software for managing data, moving it around, etc. We're not going to charge by number of servers or anything of sorts because it doesn't work.
Well, it doesn't fit the architecture.
Well, you're right. It will be counterintuitive, and it will actually form customers to put it on less and less nodes, where we shine in huge environments. I didn't give you the numbers, but we tested. I wouldn't say go and test that tomorrow, but you can try. We tested 20,000 nodes for a single brain, and you can assume the scale of that thing can be. And that's the reason, because there's no clustering. There's no shared hash maps going between those nodes. The brain holds that thing. And again, for this workload, where we keep only metadata on the brain and the data goes by peer-to-peer, and that's the points that we will cover now in the right path, this is ideal for that. Any questions before we go even deeper?
No, all my questions are about read path and write path.
Really?
Yes. Really? I think that's.
Put the agenda up?
So going back to this, what we thought we might be able to cover are read path and write path, some networking, something about security, maybe some filter. I don't think we'll cover any of it. Maybe we'll cover write path, but of course, again, this is to show you that we want the discussion.
I'm more concerned about read path, actually.
So we'll show you.
We'll do both.
We'll do both. Okay.